Hello folks. In this video we're going to be continuing the AWS Aurora Immersion Day workshop. We're going to be looking at security this time. So we'll run through security labs in this section. So previously we were looking at provision the DB cluster labs, right? Creating an Amazon Aurora database cluster manually, configuring the app parameters required. Then you will have a database cluster ready to be used in subsequent labs. So here we're looking at it's a run through of security labs in this section. So we'll be looking at managing database credentials with AWS Secrets Manager, IAM authentication to access the database cluster, set up database activity streams. So for example, here we have multiple steps and all. Let's look at it. Cool. So this lab will walk you through the steps of securely managing Amazon Aurora database credentials using AWS Secrets Manager. Okay. So just get that. Okay, so that's one reference. So the service enables you to easily rotate, manage and retrieve database credentials as well as managing access to secrets using the fine-grained policies. So there is your app, there's your admin. So you first of all put it in your personal database, and then Secrets Manager. Custom app takes from Secrets Manager, accesses Secrets Manager, gets the data, and then accesses the personal database. With steps 1 and 2, the admin creates credentials and places them in the AWS Secrets Manager. An application with sufficient permissions then can access the credentials in steps 3 and 4 to use them in step 5 to access the database. Currently, we already have one secret, right? Secret cluster admin user that is used for the admin user. So this lab contains the following tasks: create new database user and grant permissions, create new secret for the created user, manage access to the new secret using IAM policies, verify database cluster connection, enable rotation of for the secret, audit usage of the secret, cleanup, right? So we have all of these ready. Get started, connect to the VS Code ID and all that, gather prerequisites. So by the way, before we move on, I wanted to show that in the last lab, we had done modification of the standard storage Aurora lab database cluster, and the configuration has become IO optimized now. So the cluster storage configuration is Aurora IO optimized and not just Aurora standard anymore. So that change has happened and it's available now. So let's just close this for now. So we have too many things open. Let's just close some of these. Okay. Cool. So create new database user and grant permissions. So you will connect to the Aurora database just like you would do with any other MySQL based database using a compatible client tool like MySQL to find the cluster endpoint, retrieve the database. Okay, so if you have not already opened a terminal, okay, during this lab we'll use a secure connection to ensure encryption in transit. Okay, so if you haven't set up this set up this in a previous lab, let's do this now and download the certificates. Use the following command to download the RDS related certificates as a bundle into the current directory. Okay, let's do that. So this is wget and RDS combined CA bundle. So we have a PEM file. So there are a lot of certificates in this, right? Cool. So to connect to the cluster, you can use the next command. So we're already set up during the cluster setup. Okay, so we just need a cluster endpoint. Let's use the cluster endpoint, which is this, and put this in. So we get the cluster endpoint. We can actually give a space. I don't know why they don't give a space here. Anyways, so this is the one thing, and routines certificate verify failed. Okay, so that's weird. Okay, that's weird. Make sure you're using the endpoint for the writer instance of the cluster and not the reader instance. The value of the cluster endpoint can be found by following the values lab. Okay, all this is fine, but interestingly I am not able to connect. It says so SSLCA not able to verify. Using a password, connection error, SSL's routines, certificate verify, invalid. That's weird. Should I just not connect with it using SSL? Okay. Let's try something else maybe. Maybe let's say FNH database cluster standard. Yup, that also failed. What about cluster IO optimized? That also failed. So let's see if we can actually find answers regarding this. But we don't want to skip SSL though. I just want to understand why the certificate failed. So I think this is the cluster endpoint. Okay, so we'll have to connect to the database endpoint, is it? This is the writer instance. Connectivity. Yeah, MySQL node 1. Let me connect to that then. That is the writer, right? Yeah, node 1 is the writer. Oh wow, no, it doesn't pass. Doesn't work. How do I know if this supports SSL though? Connectivity. Okay, port. Yeah, oops. SSL. I can't see any SSL related stuff over here. Endpoint SSL. TLS. Actions. Take snapshot, export to Amazon S3, add replica auto scaling, elastic cache, modify, SSL, TLS, connectivity, nothing, connection, damn it. Interesting. Looks like resolve is migrate to an engine that supports SL. 2026. So we get this. SL routine certificate verify failed. Before you connect, confirm that you download the correct certificate. When you are connecting, make sure that you are using the correct certificate identifier name and the correct path to the certificate. Okay, SL mode verify identity. Is that the default mode? I don't know. I've tried different things now. For example, this is one that I tried now. First one was without these. So let's try that. So that is on. So and then next with these, I'll also put in this. Oops, no, this and this and this. Let's see if this works. Nope. Let's see if this works. Nope. All of it doesn't work. Oh, that's interesting. Okay, so I'm stuck in this point itself. Is so your application trustor only needs to register the root CS certificate. Any commercial AWS region. So we are in which region? We are in US West 2. So let's just cancel this. We are in US West 2. So bundle PEM. Let me get this. Copy link address. Right. Any commercial global bundle. Okay. Viewing the contents of your certificate. Key tool. Okay. Let me just do this. wget and then let me use that. Oh, that worked. Interesting. That worked. Interesting. So we needed the wget for that. Okay. So all these didn't work. That worked. And then for the node, I think that will work too. Yeah, that also worked. Interesting. I think I didn't get the right certificates. Anyways, that was an interesting thing to check out. Yep. Phenol. we can actually check out what is being used or what it's using. So for example, I can just say /g and we'll know what it's using. So SSL FIPS mode off, CRL and all that, certificate, yeah, the certificate is here, and data CS certificate, service out. Yeah, it does have stuff. So the thing works. Now let me actually just use the cluster URL itself, and let's create a demo user identified by secure password, and that's done. So alter user demo user at run the following. So once connected to the Aurora database, use the code below to create. Let's just close these. Use the code below to create a database user account that uses a secure password. In this lab, we'll use demo user as the database username, but you can use a different name accordingly. Run the following SQL query. Run the following command to allow the just created database user account to connect to the cluster from anywhere, but require an SSL connection. Okay, so we should require an SSL connection. Now grant the user some permissions to create or drop tables, insert and select records within the database MyLab. This will be needed later on for some testing. Okay, so grant create, insert, select drop on MyLab.start. Okay, so that is done. And finally, you can now quit the connection. Okay, quit. Next, so create new secret for the new created user. Now we'll create the secret that will hold the credential information. Open the secrets manager console. Okay, click store a new secret to start the configuration process. Okay, and in the select secret type, choose credentials for RDS database, then input the username and password that was just set up in the step before secure password. Okay, so RDS. Interesting. So I don't have access to list Redshift serverless namespaces, document database, and all that. Okay, that's fine. Credentials for Amazon RDS database, and yeah, not for these. I can't do any of these. So username, demo user. So that is the demo user, and then secure password. Secure password, right? So encryption key. So next in the select which RDS database the secret will access section, choose the database cluster identifier you assign to a cluster, Aurora Lab MySQL cluster. What is encryption key used for? The secret information is encrypted using encryption keys that you can manage by using AWS KMS, which is key management system. For most cases, you can encrypt by using the AWS managed key that AWS Secrets Manager creates on your behalf. AWS/Secrets Manager, or you can use a customer managed key that you have created in AWS KMS. If you use a customer managed key, then the IAM user or role who needs to read the secret later must have the permission KMS decrypt for that KMS key. You're not built for using AWS managed key that AWS Secrets Manager creates for you. You're built for any KMS keys that you create. Okay. So leave the encryption key as it is and click next. Okay, encryption key is the same. Okay. So okay. And database, it will be Aurora Lab MySQL cluster, and this is okay. Cool. So now secret name and description. Okay, so name the secret demo user and provide a meaningful description. Demo user credentials for the secret. Okay, so secret demo user. You can have slashes in the name apparently, and then underscore plus equal to dot at and hyphen. A hyphen at the end is allowed? Yeah, it's allowed. Space at the end is allowed? Yeah. Anyways, cool. So now we'll just say demo user credentials for Aurora Lab. It's actually Aurora Lab, not Aurora -Lab. Here it's correct. So yeah. Aurora lab MySQL, and tags, I don't need anything. And choose next. On the secret rotation page, keep rotation off for now. Okay. Resource permissions, replicate secret. Okay, optional. Add or edit a resource policy to access secrets across AWS accounts. Okay, no need. Choose a region to create a read-only replica for a secret. Nah, it's okay. Secrets incur a charge. Okay, interesting. So rotation off, and click next. On the review page, review your secret details and recognize the provided code samples in the different programming languages. Okay, so rotation is off for now. So to rotate this secret automatically, expression builder, expression 23 hours. Rotate immediately when the secret is stored. The next rotation will begin on your schedule. Create a rotation function. Use the rotation function from your account. MySQL rotation lambda. Clear function name. And then single user, alternating user. The user must have permission to update their password. This strategy clones the initial user and stores both sets of credentials in one secret. One of the credentials is always valid. You must provide admin credentials necessary. I'm not sure what this is. Anyway, secret type and secret configuration rotation schedule is like its automatic rotation is disabled. Rotation is disabled, and rotation function and all is not there. And then finally, we need Python code. We'll just copy this and then choose store. Right, so you can actually even download SDK. We will close these. So I like Go, I love Go. So there's also Rust stuff here. Tokyo is some network library, I think. And anyways, so request response and all that stuff, I guess. Cool. So now let me just go ahead and store, and just successfully stored the secret demo user. To store it in this list, choose refresh, see sample code, and okay, view details, see sample code. Okay, cool. So rotation versions is just one version, AWS current. Okay, replication, nothing. Tags, nothing. Okay, let's close this, and now hit the refresh button and click on the newly created secret. Make note of the secret's Amazon resource name, since we'll need it for future references. Okay, so where's the ARN name? Over here. ARN. Cool, so we'll keep it here. Okay, so manage access to the new secret using policies. To allow an identity like a user, a role, or a group to access the secret, an IAM policy is required. Follow the steps to create an IAM policy that grants the secrets manager get secret value action. Okay, open the IAM console, choose policies, and then create policy. Okay, so IAM policy, IAM feature policies. So I just have to say policies and it will come up. I think policies, features, right? And so here create a policy, select a service, secrets manager, or I can just put the JSON here saying action is this, or just say secrets manager, and the action is get secret value. It's a read, get secret value, and that's it. And here I think you need to add the secret URL. Select the JSON tab, paste the following, and replace the following parameters. Secret URL. Yeah, I think instead of doing that, I can actually just add resource region, or just give a text. This US bus 2, and then account and all that. This was secret, this account. So US West to, if I say any region, it will just put star again, but US West to secret underscore, okay, demo user and all that. Any account, allowing all accounts with star can create an overlay permissive policy. Other account, you'll have to give the account name, right, account number, or just say this account and it will just put this. Anyways, we'll put the text here and add ARNs and it should be done. Cool. So with that, you can click next. I think previous we can actually see the JSON, which is this. So there's no statement ID, I think, in this case. Yep, and then that's it. So now you can just say next. Policy name, you can just say click next tags, click next review. For name, enter a name, Aurora Lab IAM is access secret, and click create policy. No description, and click create policy. How to improve the access of secrets manager secret via the public internet. So permissions are set, the secret information is encrypted, and the traffic is encrypted as well. However, the traffic leaves the AWS network and traverses the public internet. In order to avoid that, we recommend calling the secrets manager API directly without having to leave your private network. Okay. AWS network and traverses. Okay. This can be done using interface VPC endpoint for secrets manager. In addition, it allows you to deny any access to the secret information by requests that don't originate from your VPC. Interesting. I think a lot of secrets, like a lot of what do you say, protection, security. Cool. Verified database cluster. Now that we've created the database user, the secret, and a policy to give permission to access the secret, let us check accessing the database. So for this verification, we'll use the VS Code ID, but it could be any other service running the desired application, like an AWS Lambda function or container image running in Amazon Elastic Container Service or Elastic Kubernetes Service. However, the current role of the instance already has permissions to access secrets. For our verification, we will therefore use a different role. Let's create a role that we can assign to the VS Code instance. So let's create a role. We'll have to create this. Create the policy. View policy. Yeah, and then roles. Create role. Here we select the policies that should be attached to this role. So service, custom trust policy, or web identity. Okay, wait. Use case EC2, role for AWS Systems Manager, Spot Fleet role, Spot Fleet auto scaling, tagging Spot instances. To launch Spot instances and attach tag to the launched instances on your behalf. Okay. Schedule instances. Okay, so here, I'll just say Aurora Lab IAM secret. Awesome. So I can also give the same thing over here. Create a role without a permission boundary. 1068, same thing. IAM and this. Cool. So now we have this. Give the role a meaningful name, Aurora Lab EC2 DB secret access role. Review the two added policies and click create role. Okay, only one policy, right? Anyways, um, role name is this, STS assume role, and then service EC2. So, and then you have created a role that can be assumed by an user or by a service like Amazon EC2. Now you will assign this role to the instance where the VS Code instance is running. Open the EC2 console, click instances on the left menu and select the instance with the name starting with Aurora Lab VS Code ID. Okay, so let's create this role first of all. Permission, policy summary, boundary, and permission. Okay. I clicked it. Okay, it's created. View role and okay. So here we have 3 instances running. We'll be choosing the VS Code ID, and here I will be looking at security and okay, probably role or IAM of sorts. Instance state, networking, security, change security groups, modify IAM role here. I think IAM should be, oh yeah, it's present here, IAM role, right? Can you modify the IAM role? I'm guessing they are going to modify it. It can only have one role, I think, yeah. Modify IAM role and note down the name of the current role for later use, then select the just created role and click update IAM role. VS Code instance now assumes this role to call any AWS services on your behalf, as we can see by issuing the following command: get caller identity. So basically you can change the IAM role over here, actions, security, modify IAM role, and choose this role, for example, right? Okay, update IAM role. I think you know the older role because I don't remember it now. Actions, security, modify IAM role. I think it was this US West 2, right? So now that it has this IAM role, security role, I can actually say AWS secrets manager. See, I can't get this value now. I think it will give error. I think. See, so it is when calling the secret assume role Aurora Lab EC2 DB secret access role is not authorized. So this is the instance name 0276 BFC at the end. So yeah, is not authorized to perform get secret value on resource this, right? But you can get the resource on get secret on another secret ID, which is this, right? So you can get it. Awesome, cool. So now get caller identity, so you can check the identity of this user, right? So this is EC2 DB secret access role. Cool. So I can actually put this in here. Okay, so now there is already a small script DB access test connecting to the database cluster using the previously created secret without having stored the credentials somewhere in the code or environment variables. Open the file and examine its content. What it does is using the AWS SDK to create a client for the session manager and retrieves the secret by the name given via the command line argument. Then it uses the secret to extract host, username and password to access the cluster and execute a small query showing existing tables in MyLab database. So let's copy this. Try executing the script with the following command with the previously created secrets name secret demo user. So this. Oh, Python command not found. Interesting. Python. I think it's Python 3. So it's Python 3. I think every time we wrote Python 3 only. Yeah, Python 3. In this case, we wrote Python Dynasty. Anyways, so it says can't connect to MySQL server on this SSL certificate verify failed, unable to get local issuer certificate. Okay, so the output should look like the following. Well, but how do we know the access of the secret is only possible because we have granted access? We could remove the policy from the role and see what happens. Activate the checkbox of the thing and click remove. Oh, interesting. Cool. So now, first of all, I can't access it without certificates, I guess. So db access. Wow, this takes so much time to open up a file that is already there. Over here, how many files are there over here? That's all. db access test. Oops. db access. If I close this, I think access test. Wow. If I do underscore dot py, can it? No. Weird, something wrong, but anyways, I'll just close this for a moment. Oops. Let me just pull this up. Show the terminal. View Explorer terminal. Cool. So this script will allow you to test accessing the cluster using a secret in AWS Secrets Manager. So does it have SSL though? So basically this is going to be wrong. This is not the correct one. So I'm just going to actually change this to it's going to be US West 2 bundle, right? It's some weird thing, US West 2 bundle.pem. So now let's connect and this should work. Yeah, Joe, Bob, Mary, added 3 times to Aurora MySQL table, connect to the desired table, SSL, auto commit true. Okay, cool. So if you don't provide SSL, I think it's going to be a problem. So for example, if I try to use maybe this and say same thing, the user is demo user, password is secret password, but I don't use this. Okay, if I just use this, I think it will not work. It will say access denied for user using password yes. So you are using the password yes, but you need to use this bundle. So you need to use the SSL or else it will be failing. Oh wow. Looks like using a and wow, why is it failing? Let me check one moment. Let me put this and let me actually remove this. And wow, okay. Not sure why that is happening. So username, password, database is MyLab. Auto comment true, connection timeout. Okay, how come this worked and not this? US West 2 bundle. Interesting. So let me see what these are. Let me print these. So they are printing down some of these things, right? So let me print this. Print the host. Actually print everything. I want to print this and basically so print print. Let's just type print thrice. Okay, wait one moment. Yeah. Print. Okay. So now we can just say this. Let's run the Python thing, secret demo user. So it's this demo user. Oh, it's not secret password, sorry, secure password, damn it. Remove this. First say secure password. Oh, it passed. Interesting. If you give SSL, does it still work? Yeah, it works. If you give this, file won't be open, so default verify paths fail, so even the thing is not available. But if you say RDS something, it will fail. Cool. So it was just a matter of this one is path is wrong. There was no such file, but anyways. So it's just secure password, not secret password. I forgot the password basically. It's okay. Secure password, and that should just work. Cool. So it works. So now if you go and actually try out this thing, and so let me just comment these, and now if I actually go and remove the policy, right? Policy. So here if I actually select the instance, so select the original starting with AID, okay. So you should, so basically if you go to the policy, activate checkbox, policy and remove. So if you go to the role, not even policy, sorry, the role that we just created, this one, right? So oh, this was created just a few minutes ago. Anyways, EC2 DB secret access role. If I just remove this, right, permission boundary is that, okay. If I remove this, remove boundary, right, and then finally can I run this again is the question. So click remove, give it a couple of moments to be propagated, and then try executing the script again. So now it will give error, so you can't do this action, right? So yeah, as you can see, it is not possible to access the secret and connect to the DB cluster without sufficient permissions. To proceed with further steps, let's quickly set the IAM role for the AS Code ID instance back to what it was. So EC2 console, and instances, and this modify IAM role ID US West 2. Cool, it's done. Now I think it should be able to access. Yeah. Cool. So it should now state the correct IAM role. So security tab IAM role, yeah. Again. So do I need to retrieve the secret every time I need it in my application? Well, it is up to you. While it is possible to retrieve the secret with get secret value every time you need it, we recommend caching the secret values by using the client-side caching. There are caching components available in many SDKs. So they recommend caching. So yeah, cool. So enable rotation for the secret. Okay. So this was just managing, and then IAM authentication, database activity streams. Okay, cool. I think it's pretty fast. I mean, we are going pretty fast only. So You now have an option to avoid storing the credentials inside the code or within environment variables. Okay. But there is still a problem that still remains. Usually, it is required or at least strongly recommended to periodically change or rotate credentials. This is the moment where the AWS Secrets Manager can help even more by providing a fully automated feature to rotate your Amazon RDS, Amazon Document DB, and Amazon Redshift secrets. Yes, you can also rotate the other types of secrets. Can I also use the rotation feature for other types of secrets? Yes. Okay. So to enable the rotation option, open the Secrets Manager console. Okay. And then on the secrets page, choose the previously created secret demo user. Okay. And then on the secret details page, in the rotation configuration, choose edit rotation. In the edit rotation configuration dialog box, do the following. Under configuration, configure automatic rotation. Turn on automatic rotation. Okay. And then in rotation schedule, set time unit to 30 days. Rotation schedule time unit to 30 days. I say 1, it will not say day, it will say days. So to 30 days and leaving the remaining values as is, especially the rotate immediately when the secret is stored. The next rotation will begin on your schedule. Needs to be remain enabled as you want to see the first rotation immediately. Okay, so rotate immediately when the secret is stored. And you under rotation function enter a meaningful function name Aurora rotation lambda. Okay. Aurora rotation lambda, and there's nothing I think. Aurora large support. I think I'll just use this. So click save. Okay, so 30 days, no window duration and all. So schedule expression builder, schedule expression. Okay. Yeah, 30 days. Use separate credentials to rotate the secret. This user must have access to update their password. Alternating users. What happens behind the scenes? What happens now is that Secrets Manager will create and deploy a CloudFormation script to create a Lambda function to actually perform the rotation, and a secret rotation schedule to invoke the Lambda function at the specified interval. So the function updates the password in the database as well as in the Secrets Manager. Wow. In the rotation configuration, the status field tells us the rotation is being enabled. Tells us the rotation is being enabled, and then now let's check in the CloudFormation console, and the stack creation is completed. Okay, so let's just save, and once the stack creation is finished, it can take approximately 5 minutes to complete. So you can actually see create in progress, right? Let's click this. So events. So it's create in progress. So secret rotation schedule hosted rotation lambda. Okay, what is that? It's a stack again. Okay, so stack info. Okay, so logical ID and all that. Okay, RDS MySQL rotation single user 30. Okay, resources. So resource creation initiated module. Okay. So events is this. So it says nested, so I think it's one more stack has been created inside. Once the stack has been created, we can check the secret to be updated. So go back to the secrets manager console, select the secret, select demo user, secret demo user, and retrieve the secret value. You can see the details of the rotation like status, interval, and function on the top right corner. You may also recognize a new button allowing you to perform an immediate rotation. So if you actually go here and say retrieve secret value, secure password, and okay, rotation is being configured. Let's actually refresh. Retrieve secret value, actions, and rotation is disabled. What? I enabled it just now. Huh? I just enabled it. I thought I enabled it. It should be enabled now, right? Is being configured as setting up rotation resources. This could take up to 2 minutes. Okay. So it says create in progress. So yup. In this, the resources is basically this. Rotation single user 3012 secret rotation schedule hosted rotation lambda. Okay. Okay, this one says create complete. Interesting. Let's see if this is still. Yeah, it's enabled now. So your secret demo user is successfully configured for rotation. Use the sample code in your application to retrieve the secret. And if you actually check out this secret overview, get secret value, it's changed now, right? So like status, interval, and function. So on the top right corner, you may also recognize a new button. Yup, allowing you to perform an immediate rotation. Okay. So to see if it also was changed on the database, execute the script again. You don't need to change the IAM roles for the instance, since the current role already has the rights to access secrets throughout this account. Okay. Cool. So let me go ahead and access this. And Python not found. Is this Python 3? Yep, it works. So we can actually even check out the password. Yeah, the password is something different now. Cool. So with that, now let's look at congratulations. You have just set up a highly secure and fully automated way to use periodically rotated credentials in any application. This does not only remove the undifferentiated heavy lifting, it also helps minimizing the attack surface as well as being compliant. Interesting. It's pretty complicated, something to think about. Anyways, sometimes it might be necessary to audit the usage of the secret. As you might already know, API calls can be connected in the audit trail. So CloudTrail, this is also the case for the get secret value operation. So cloud formation, this and all I can close, and maybe lambdas are it ran, is it? Run code without thinking about servers, it seems. Anyways, rotation, yeah, this is the one that ran. Yeah, it gets, there's no trigger per se. So code is this lambda handle. I think this is the code that lambda itself has written up for secrets manager RDS MySQL handler. This handler uses the single user rotation scheme to rotate an RDS MySQL user credential. Logs into the database as the user and rotates the user's own password, immediately invalidating the user's previous password. So basically it has to go talk to the endpoint, right, and then basically talk to secrets manager, rotate it, talk to database, rotate it, and then finally so this is the whole code. Maybe we can actually check out this code. Can I, oh, we can only upload to this code. Can we download? Deploy, test, settings, use your snippets. Lambda deploy, okay. So I think I'm just gonna see if I can actually get this code. Throttle actions, publish new version, download, function code, zip file, SAM files. SAM is, I think, the template has been generated from the functions configuration. So I think this is something specific. Okay, let's download both. And did it download? Okay, so it's going to download here. So it's a zip file. This function belongs to an application. Click here to manage. Okay. Cool. So this is an application. Okay, set up your development environment, Cloud9 or JetBrains or SAM CLI. Okay. Serverless application module. I don't know what that is. Is it that? Serverless application model, yeah. Not module, model. Anyways. So so with that, access denied, you don't have permission to access the resource. Okay, so choose event history and filter for get secret value. So you don't have any permissions to access this resource. Interesting. Just a moment, let me charge my laptop. Okay, cool. So you can now enrich CloudTrail events with additional information by adding resource tags, and IAM global keys in CloudTrail Lake. Okay, something similar to Data Lake, I guess. Okay. So in event history, so it says access denied for some reason. Describe configuration recorder status. I don't know. Configuration recorder. Okay, I think you can record configuration, right? Now I think that is not there. So you cannot do that, I think. Before you could record the thing. I think something about recording configuration. Yeah. I think this one I don't have access, I guess. I don't know. To load configurations, recording configuration, don't have permission. Create. I don't know. Anyways. So here event name, event time. So I can actually search for events, I think, and filter for get secret value. So how do I look for this? So gets also no. Read only no. Action, event name, resource name no. Get secret value, username. So I think we are looking for event name. Okay. So it's the event name. Get secret value, right? So now you have a lot of these. So you can actually see username is so for example I got the secret once, and then the instance EC2 instance got it twice, and then the lambda function got it like 3-6 times. I got it a lot of times, 2, 4, 5. So yep, secret manager role assumption. So yeah, there's a lot of it. There are 2 pages by the way. So yep, system, and then Aurora lab secret plain text lambda participant and whatnot. Cool. So you should see different calls. Some were made by the VS Code instance when we issued the test script. Some calls came, so yeah, the instance because we were running the test script or we were running say AWS CLI commands. Some calls came from the rotation function, and there might also be calls from your currently logged in user when you retrieve the secret via the console. Yep. Depending on the roles you will create and the secrets being set up, you are able to exactly track and audit access to a specific secret. Yep. Clean up resources. To remove all resources from this lab, open a terminal in VS Code and then cluster endpoint. Okay, so let's do this and bash. So cluster endpoint, I think we'll have to put this here. Cluster endpoint is simply this, and let's get this going. Database user, delete the policy, delete the role. If you delete the policy, and however the policy will remove the policy from the role, but yeah, it would be an interesting thing to see what happens when you delete a policy without deleting the role. Let's go to the role and put that policy in it. This one, EC2. Let's put a policy here, add permissions, attach policies, and IAM secret, add permissions. So now, what if I delete this first? Let's drop this first. Certificate invalid, okay. Oh yeah, this has to be different certificate. US West 2, US West 2. Okay, that is done. So let's delete the policy first. I want to see what happens. When calling the delete policy, cannot delete the policy attached to entities. Cool. Can you actually see what entities a policy is attached to? Let's say I am just looking at this. Entities attached. Okay. So if you remove this, detach, we'll lose all the permissions defined in this policy. Detach. It's gone. Okay, so even in the policy you can go ahead and detach the thing. So yep, cool. So now you can actually run it. Yep, and then now if I try to do something, attach or whatever, let's say attach tags. This should give an error. Yeah, policy was not found. Nice. Policy versions. Show the version. This is already there. Last accessed. Permissions. JSON. Edit. Interesting. So there is no edit. Next, save change, and it will say does not exist or is not attachable. Cool. So the policy does not exist, so cancel. So yeah, I think if you simply reload this, oops, you'll be able to notice that there will be an error. Yeah, it was not found. Cool. So finally you can actually delete the role. Instance profile, which one? Looks like there are some instance profiles. Revoke sessions, revoke active sessions, acknowledge and revoke active sessions. Currently active sessions. So this action can be undone by detaching this policy. You can continue to create new sessions based on this rule. I don't know, what does that mean? And by detaching the policy, I don't know. Anyways, permissions, it doesn't have anything. Revoke older versions, remove. What is this? Yeah, I don't want this basically. Revoke older sessions, I don't know. Oh, this should have permission to do that, okay. AWS revoke older sessions. Interesting. So if I do revoke active sessions, so it says deny resource date less than, okay. So it's basically creating this. So it says deny. So this is what comes up, and everything is denied basically. So if you want to undo this, you can actually just can we undo by detaching the policy? You can continue to create new sessions based on this rule. So okay, so let's just remove this. Remove AWS revoke older sessions. Delete. And why can't I delete this permanently? It says it got removed. Very interesting. Weird that it won't. Now it will say it's not there. Anyways, I don't know why this happened. Must remove roles from instance profile. I don't think anything had it. Anyways, finally, I think we're done here. So IAM authentication to access the database cluster. We'll come to this, and we'll also be doing database activity streams. It's pretty late now, so I'm just gonna go ahead and do this tomorrow morning. Hopefully I'll have the time to do this. So that's all I had for this video. I'll see you in the next one. Bye bye.